Okay, so what we're going to do is we're going to talk about proton NMR. And I think in one of my videos earlier, I wanted to talk to you about something called, where's the word here? Can we see, find the word here? It's called splitting. Okay, it's called splitting, and where is it? And the n+1 rule. Splitting and the n+1 rule. So I want to explain this to you thoroughly. What does this all mean? So let's say, okay, I'm going to add a page here. Okay, so let's say we have a signal, right? Let's say we start with something simple. Let's say we have carbon. Okay, we have carbon, and then let's say we have another carbon, and we have another carbon. So this was the what I showed you earlier. All right, so these purple hydrogens are in the same environment, and these yellow hydrogens are in the same environment. Okay, so what happens is, since there is a symmetry, the signals which are produced by this hydrogen, okay, so I'm going to combine all of them together. Okay, the signals that is produced by all of these hydrogens, so they will all merge and then they'll become one big signal. All right, let's say they become one big signal. All right, so they all merge together. All right, imagine that. So what happens is, the neighboring hydrogens will split the signal. Okay, will split the signal in this case in two places. Let's say something like this. Oops, what did I just do? Will split in two places like this. Okay, just imagine that. So when the two hydrogens of the neighbors split that signal, how many parts do you get? You get one part here, and then you get another part here, and you get another part here. So you get 3 parts, right? Okay, so the signal, okay, the signal that appears for the purple hydrogens, instead of coming out as one line, it will come out as 3 lines. One line which is taller and 2 lines which are shorter. It will come out like this. Okay, but usually it appears something like this, like something like a mountain like this. It will appear like this. All right, this is called a triplet. And these hydrogens, the signal is exactly the same. They are exactly, so this signal also is exactly the same. So this signal that comes out here, this signal that comes out here, and then they all merge and they all become one big signal, which is exactly the same. They are both the same frequencies. All right, both the same frequencies. And okay, let's go back in time. Okay, if we go back in time now. All right, let's remove everything here. Wow, oops, what am I doing? Sorry. Okay, now if we focus on the signal which is produced by these hydrogens now, okay, so this yellow hydrogens will produce one signal. Imagine it's producing a signal like this, right? What happens is, these 3 purple hydrogens on the right and these 3 purple hydrogens on the left will split this signal in 6 places, because there are 6 of them. We'll split it in 6 places, right? So 1, 2, 3, 4, 5, 6. We'll split the signal in 6 places. So how many pieces do you get? You get 1 piece here, 2, 3, 4, 5, 6, 7. You get 7 pieces. Wow, you get 7 pieces. So what happens is, the signal, when it appears on the scale, instead of appearing just as one line, it appears as 7 lines. So the 7 lines will be something like this. One line will be tall, then the next line a bit shorter, and then the line after that a bit more shorter. Okay, 1, 2, 3, 4, and then the next line a little bit more shorter. It'll appear like this. But of course, when you actually look at this, when you look at it, right, it will appear something like this. Scale. It appear like this. All right, so this is called a multiplet. Okay, it's called a multiplet. Okay, multiplet, or the exact word for this is actually called septet. This is called a septet. All right, so it will appear as a septet. So this is called splitting. So the idea here is, the signal which is produced by a set of hydrogens, the signal is split by the neighboring hydrogens following an n+1 rule. Okay, so let's look at this one. Where was it? Okay, let's look at this, right? Let's look at something simple here. Look at this. So in this case, Okay, so we are taking chloromethane here. So if we look at chloromethane, so let's say we draw it out like this, right? So this is the chlorine, this is, let's say, the purple. Okay, let's change color. Okay, so let's say these are the green hydrogens, and let's say these are the pink hydrogens, pink hydrogen, all right, pink. Okay, so the signal which is produced by the pink hydrogens, okay, the signal which is produced by the pink hydrogens is split by the green hydrogens. And since there are two green hydrogens, so we follow the rule n plus 1. So 2 plus 1 will be 3. So the signal that appears for the pink hydrogens, right, will appear as a triplet. See, it will appear as a triplet. This is how the triplet looks like. So you see these two lines. You see these two lines are a little bit shorter, and then this line in the middle is a bit taller, right? Then the green hydrogens that produce a signal, their signal is split by the pink hydrogens on the left hand side. Since there are 3 pink hydrogens, the green signal is split into 3 plus 1, a quartet. So the quartet looks something like this. So these two lines are about the same height, and then these two lines are about the same height. So that's how a quartet looks like. And in the case of ethanol, here, if you look at ethanol, so you have something like this. All right. So pay attention to this, okay? So if you look at over here, right, what I want to explain to you is the signal that is produced by this hydrogen is not split by anybody, because the neighbor, it's actually the hydrogen is connected to oxygen. It's not connected to another carbon. So only if it's connected to a carbon, and that carbon contains other hydrogens, but currently it's oxygen, so it's safe. That is why it only appears as a singlet here. That means it's not split. Nobody can disturb the signal. Then we are left with these guys here. So this green, all right, their neighbor has a carbon, and that carbon has 3 hydrogens. So their signal will be split by 3 plus 1, 4. So this is the signal by the green hydrogens. Meanwhile, for the purple hydrogens here, what happens is they have 2 green neighbors. So 2 plus 1, 3, their signal appears as a triplet. But obviously, I hope you also can see that the triplet is taller than the quartet, and the quartet is taller than the singlet, because their ratio is 3:2:1. That's the ratio that you will get. Okay, so that basically is the splitting of the hydrogen NMR, right? And that concludes NMR. So you need to do practice. You got to look at all the worksheets and do some practice, right?